When you hear someone say tools for machine learning, then it feels somewhat natural that people would go, oh yeah, that sounds like Scikit-Learn. It's a really cool library, it's been around for a decade, so yeah, it makes sense that people think of Scikit-Learn. But now if you were to do the same thing and you were to say, well, let's talk about tools for image classification, then your first inclination might be to think of libraries like PyTorch, maybe Keras, but your initial thought might not go to Scikit-Learn in this particular case. And that might be because Scikit-Learn historically has been great for doing predictions on tabular data. That is to say, data sets that have rows and columns. But the interesting thing here is that theoretically nothing is stopping from Scikit-Learn to do image classification as well. And that is something I would like to discuss in this video. You can construct Scikit-Learn pipelines to do image classification if you'd like. You just have to make one or two changes. And I hope that by demonstrating this one trick, you get to appreciate a very powerful general pattern here. Now, before diving into the main trick of this video, I would like to take a small sidestep to just talk about Scikit-Learn pipelines in general. And I'll be using this code over here as a tangible example. What I'm doing here is I'm creating a Scikit-Learn pipeline, and that's a sequence of components that together form kind of an end-to-end model, you could say. The particular pipeline that I'm defining over here first accepts a standard scaler, which is a component that will scale numeric values that go in, and the output of that is passed to this linear regression model over here. If you have a modern version of Scikit-Learn in a Jupyter Notebook, you can get this fancy output to appear if you're going to inspect your pipeline. But let's now talk about what's actually happening in here. This is a pipeline where at the end we have a model, so to say. And a model component has a method .predict. The way that you could see this is that we have input to this pipeline that is going through all the different components, but eventually it can go to this model, and that model is able to make a prediction. However, this pipeline also has the standard scaler over here, and this is a component that has a transform method instead. And from the perspective of the pipeline, there's actually something very interesting with these transformers, you could say. You see, from the perspective of the pipeline over here, the pipeline really doesn't care what this transformer does exactly. In this particular case, the transformer will receive something and will pass it on, and for the pipeline to work, what we're passing on here needs to match what this model is expecting. But again, from the perspective of the pipeline, that's kind of just about it. We're really just dealing with a Python object here that can still learn from data, but the type of object that goes into a transformer doesn't necessarily have to be the type that goes out. It can be very common for something numeric to go into a transformer and for something numeric to come out, but from the perspective of the pipeline, this doesn't necessarily have to be the case. And the reason why I'm emphasizing this is because this allows us to do something quite powerful. So let's dream up a new pipeline. And while we're at it, let's also assume that this pipeline will actually receive images. So an image is going to go in. And at the end of the pipeline over here, again, we would like to have some sort of a model, a Scikit-Learn model preferably. And that means that this model needs to get something numeric going in. That can be fine. If we want this pipeline to work, the one thing we just got to do is put a component in here that is able to accept an image and emit something that's numeric. And there's lots of ways that you could do that, but one thing that we could do is we could take pre-trained neural networks that act as an encoder, so to say. And another way of putting it is that we're going to use models to come up with image embeddings. And it's those image embeddings that we are then going to be passing on to our model over here. Now, what's kind of interesting and cool about this is that because it's a Scikit-Learn pipeline, we're definitely free to swap out different models over here. We can use logistic regression, we can use a support vector machine. It's a Scikit-Learn pipeline after all. But the same would also hold for this encoder. We will need a good implementation, of course, but But as long as we have a Lego brick, so to say, that we can put in here, we can also swap it out. And to show off how you might be able to do this trick for images, I would now like to show you a demo of a library called Embetter. Now, full disclosure, this is a library that I maintain, but this library actually contains components to do exactly this. It has these featurization tricks that allow you to accept images and pass them on to Scikit-Learn models, which I do think is a very neat trick. So let's demo that. So what I've done is I've made a new pipeline. The pipeline is over here, and in this pipeline I'm using something called an image loader, which is from the Embetter library. And I also have something called a clip encoder. So that gives me a pipeline that looks like this. But let's now have a look at what these components do intuitively. So let's take that image loader. And let's see what happens if I were to use that to transform something. And what I'm going to give it is I'm going to give it an image that I have on disk here. I have a folder here called pets, and there's lots of images of pets in that. But if I were to give it a path to a image, what comes out over here is a PIL object, which stands for the Python image library. And this object represents an image, and that is a type of object that this model over here can accept. In particular, this clip encoder is a very fancy pre-trained multimodal model. So this encoder could theoretically accept both images and text. But looking at the pipeline over here, you would have text going in that represents a file path. Then what comes out is a Python image library object. That will go into this clip encoder, and that will give me something that's numeric going out. And I can actually show that by calling transform on the pipeline. So here we can see it's definitely like a long array of numbers. And that also means that I could follow up that part of the pipeline with a logistic regression. And there you have it. This is an end-to-end system where images can definitely go in and predictions can definitely go out. So now, just to get a bit of an impression of how well this system might perform, I figured I would run like a very small benchmark. So what I'm doing here is I've got my image embedding pipeline, which I've mentioned earlier, and I've got this model that I would like to train after it. So I'll be training a logistic regression model after this featurization is happening. But the way that I'll be doing that is in two phases. What I'll do first is I'm going to take all of my image paths and I'm going to calculate the features or embeddings for them first. Now the reason for this is that this can actually take a small while. So in total that took about 11 seconds. But now that I've got these features, I can actually run some cross-validation scores, and this model will retrain on different subsets of the data without recalculating this part. So that should save a bunch of compute time. And there we go. I ran this model, did cross-validation 5 times, and looking at it, the scores are not bad. The lowest is about 85%. And definitely feel free to take this with a grain of salt. It's not my goal here to suggest that this is a perfect benchmark or anything. But if only for rapid prototyping, I will say, hey, this way of working is just kind of nice. If you're already used to Scikit-Learn and you want to do image classification, you can totally do that with a Scikit-Learn pipeline. You can still have that feeling of swapping out components in your end-to-end system. And the reason why I feel that this deserves to be emphasized is that this is also a very powerful feeling that I always get when I work with Scikit-Learn. The pipeline system that you get from Scikit-Learn is very flexible, and especially because there is an ecosystem of tools, you might actually be more flexible than you might think. And that's just a really great feature.